بسم الله الرحمن الرحيم.
Assalamu alaikum dear students. I hope you all will be fine and happy. Class 9 subject chemistry chapter 3 page 82, and today our topic of discussion is a shielding effect. Shielding effect. Dear students, as we know that the electrons in an atom are distributed in various shells or orbits. Electrons in an atom are distributed in various shells or orbits, and they are revolving around the nucleus in these various shells or orbits. Electrons in an atom are distributed in various shells or orbits, and they do what? They are revolving around the nucleus in these shells or in these orbits or in these energy levels. For example, magnesium, whose atomic number is 12. And atomic number is the number of electrons or protons. So atomic number 12 means there are 12 electrons with the magnesium. How many electrons? 12 electrons with the magnesium. If you talk about its structure, so the 2 electrons will be placed in the first shell, 8 will be placed in the second shell, and the remaining 2 will be placed in the last shell. This shell is called K shell, it is M shell. This is K shell, that is L shell, and the third one, this is called the M shell. K shell can accommodate 2 electrons. K shell can accommodate 2 electrons. L shell can accommodate 8 electrons. M can accommodate 18, but there are how many 2 electrons are there? So the remaining 2 electrons are placed in the M shell. So 2 plus 8, 10, plus 2, 12, and the atomic number of magnesium is 12. So dear students, this shell is called valence shell. This shell is called valence shell, and the electrons which are present in this shell are called valence electrons. This shell is called valence shell, and the electrons which are present are called valence electrons. The mean M shell is called valence shell, and the electrons which are present in M shell are called valence electrons. This K and L shell, this one and this, these shells are called inner shells, and the electrons which are present, these electrons 2, 8, these electrons are called inner shell electrons. This shell is called valence shell, outermost shell or last shell, and the electrons which are present in this valence shell are called valence electrons. This shell, first and second, K and L, these shells are called inner shells, and the electrons which are present in these shells are called inner shell electrons. So dear students, the valence shell electrons, the valence shell electron, outermost shell electrons spend most of their time away from the nucleus. These valence shell electrons spend most of their time away from the nucleus because they do not feel the full effect of the positive charge of the nucleus. These valence electrons spend most of their time away from the nucleus because these valence electrons, these electrons do not feel the full effect of the positive charge of the nucleus. Why these electrons spend most of their time away from the nucleus? Because these electrons, the valence electrons, do not feel the full effect of the positive charge of the nucleus. So why these electrons spend most of their time away from the nucleus? Why these electrons are not fully attracted by the nucleus? Why these electrons do not feel the full effect of the positive charge of the nucleus? So the reason behind is that the inner shell electrons, this is nucleus positively charged nucleus, and these are inner shell electrons. So the inner shell electrons make a shield. The inner shell electrons make a shield between the nucleus and valence electrons. The inner shell electron, these are inner shell electrons, and this is valence electron. So why these electrons do not feel the full effect of the positive charge of the nucleus? Why these electrons spend most of their time away from the nucleus? So the reason behind is that the inner shell electron, these shell electrons make a shield, makes a screen between the nucleus and the valence electron. These inner shell electrons make a shield, or screen between the nucleus and the valence electrons, outermost electrons, and as a result the force of attraction of the nucleus for the valence electron decreases. As a result of the shield or screen, the force of attraction of the nucleus for the valence electrons decreases, and hence this valence electron is not fully attracted by the nucleus. This valence electron is not fully attracted by the nucleus. This valence electron, the nucleus do not apply the full positive effect, do not fully attracted by the nucleus, and this reason is that the inner shell electrons do what? They makes a shield between the nucleus and valence electrons, and hence as a result a reduction occur in force of attraction of the nucleus for the valence electron. As a result of the shield or screen, a reduction occur in force of attraction of the nucleus for valence electrons, and this reduction in force of attraction of the nucleus for the valence electron, this reduction in force of attraction of the nucleus for the valence electrons by the inner shell electrons is called what? Is called shielding effect. The reduction in force of attraction of the nucleus for the valence electron, the reduction in force of attraction of the nucleus for the valence electrons by the electron present in the inner shells is called what? Is called the shielding effect. The reduction in force of attraction of the nucleus, the reduction in force of attraction of the nucleus for valence electrons by the inner shell electrons is called shielding effect or screening effect. The reduction in force of attraction, these inner shell electrons make a shield between the nucleus and the valence electron, and as a result the valence electron do not feel the full effect of the positive charge of the nucleus. As a result, a reduction occur in force of attraction of the nucleus for valence electrons, and hence this electron is not fully attracted by the nucleus, and this reduction in force of attraction for the valence electrons by the inner shell electron is known as a shielding effect, or it is also called a screening effect. Shielding effect or screening effect. Now I am coming towards the trends of shielding effect in periodic table, that in periods and in groups what will happen when we move from left to right or when we move from top to bottom. So a reduction occur or an increase occur in the shielding effect. Trends of shielding effect in periodic table. Trends of shielding effect in periodic table. So first I am going to discuss the trends in groups. Trends in groups. Dear students, when we move from top to bottom in the groups in the periodic table, shielding effect increases. When we move from top to bottom in groups in the periodic table, what happens? An increase occur in the shielding effect. For example, when we move from top to bottom, what happens? Shielding effect increases. Shielding effect increases. Why shielding effect increases when we move from top to bottom? For example, group number first A, which contains elements such as hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Group number first contains elements such as hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So this is called group number first, and this is called period number first, this is period second, this is period third, period fourth, fifth, period sixth, and this is period 7. So when we move from top to bottom in groups in the periodic table, what happens? Shielding effect increases, because as we know that when we move from top to bottom, what happens? Shell after shell is added in each period, and I have already told you that the shell period number indicates number of shells. Elements which are present in period first means that they will have one shell. Elements which are present in period second means that they will have two shells. Elements which are present in period third means that they will have three shells. So when we move from top to bottom, what happens? The number of shells increases. Shell after shell is added in each period. Number of shells increases, and we know that in shells what are present? In shells electrons are present. Number of shells increases means the number of inner shell electrons also increases. When we move from top to bottom, what happens? Shell after shell is added. First, second, first shell, two shells, three shells, four shells, fifth, sixth, seventh shells. So when we move from top to bottom, number of shells increases, and in shells what are present? Electrons are present. So with increasing number of shells, the number of inner shell electrons also increases. The number of inner shell electrons increases. Number of shells increases, so the number of inner shell electrons also increases, and as a result, these electrons more effectively shield the valence electron. They do what? More effectively shield the valence electrons. As a result, what happens? These electrons, these increasing number of inner shell electrons, they do what? They more effectively shield. They more effectively shield the valence electrons, and hence, as a result, the force of attraction of the nucleus decreases for the valence electrons, and hence what happens? The force of attraction of the nucleus for the valence electrons decreases, a reduction occurs, and hence we say that the shielding effect increases when we move from top to bottom in groups, and the result is that the shells increases. With the increasing number of shells, the number of inner shell electrons increases, and when the electrons are more more, so they will effectively shield the valence electron from the force of attraction of the nucleus. They will more effectively shield the valence electron from the positive charge from the force of attraction of the nucleus, and hence as a result what happens, its force for the valence electron decreases, and we say that the shielding effect increases when we move from top to bottom in groups. Now trends in periods. So when we move from left to right in the periodic table in periods, what happens? Shielding effect remains constant. There is no change in the shielding effect. When we move from left to right in periods, what happens? Shielding effect remains constant. Shielding effect remains constant. What happens? Shielding effect remains constant. No change occur in the shielding effect. So why when we move from left to right, why change doesn't occur in the shielding effect? Why shielding effect remains constant? So as we know that when we move from left to right, what happens? Atomic number increases. And atomic number is what? Number of electrons or protons. When we move from left to right in periods in the periodic table, what happens? Shielding effect remains constant. Why it remains constant? Because atomic number increases. Atomic number is the number of electrons or protons. So when we move from left to right, the atomic number increases, means the positive charge, nuclear charge increases when we move from left to right in the periods. For example, period second, which contains elements such as lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Period third, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. And period fourth contains potassium, calcium. So when we move from left to right, what happens? Atomic number 3, 4, 5, 6, 7, 8, 9, 10. When we move from left to right, what happens? Atomic number increases. Atomic number is the number of electrons or protons. So atomic number increases means positive charge. Nuclear charge increases. What happens? Nuclear charge, positive charge on the nucleus increases. When we move from lithium, atomic number 3 means there are 3 positive charges, 4 positive charges, 5 positive charges, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So when we move from left to right, what happens? Atomic number increases. Atomic number means the positive charge. Nuclear charge increases. Nuclear, moving from left to right, what happens? Nuclear charge increases, and finally this increasing nuclear charge wins over the shielding effect, and shielding effect remains constant when we move from left to right in the periods in the periodic table. What happens when we move from left to right? Atomic number increases. Atomic number is the number of protons or electrons. So when we move from left to right, atomic number 3, 4, 5, 6, 7, 8, it increases. It means that the positive charge, nuclear charge on the nucleus, positive charge on the nucleus increases, nuclear charge increases, and hence consequently this increasing nuclear charge wins over the shielding effect. This increasing nuclear charge, this increasing positive charge wins over the shielding effect, and hence shielding effect remains constant when we move from left to right in periods in the periodic tables. Okay students, it is enough for today. Now note your homework. Define shielding effect. Question 2. Give reasons that why shielding effect remains constant in periods and increases in groups. Define shielding effect and give reason that why shielding effect remains constant in periods and increases in groups. So okay students, wassalam.
اللهم انفعنا بما علمتنا وعلمنا ما ينفعنا وزدنا علما.